Good evening, everyone, and welcome to my group's presentation on the Havilland Comet plane crash of 1954. My name is Jabari Garowe,
I'm Isaac Wagner.
I'm Jordan here.
and yeah, we're about to get started. So, initially, what happened? The Havilland Comet was the world's first production commercial jetliner. It was produced in Great Britain. In January 1954, the Flight 781 heading to London experienced some explosive decompression where all 35 passengers and crew were pronounced dead on the site. It was believed that the engine turbine exploded mid-air. The planes were investigated and they were allowed to fly once again. The explosive decompression actually occurred again a few weeks after, killing 21 people. Another investigation led to the conclusion that metal fatigue in the forward window caused the explosive decompression to happen. How was the crack and failure discovered? So fatigue failure occurred in the windows near the front of the plane. The plane wreckage and passenger bodies were examined for damages, and the turbine was reinforced to avoid explosion. But unfortunately, the next plane still exploded. The consequences of the failure. So initially, we have the plane failing in mid-air. Two separate planes experienced explosive decompression, and finally, all passengers died in both explosions.
So, how was the cause identified? So, there was testing done along key points of the aircraft for ultimate stress, and a pathologist, Antonio Fernari, studied the bodies of the deceased passengers, and they found that they had ruptured lungs and fractured skulls, and things that didn't seem to match the actual description of the failure of the plane. So, to analyze this, they built a second similar plane cabin where they put in dummies into the plane seats and they depressurized it similarly to what happened in the actual event. And they found that there were similar injuries with both ruptured lungs and a fractured skull. But some other higher ups overruled this hypothesis that it was cabin depressurization. So they just decided to uh, reinforce the turbine engine instead, which didn't work because obviously the second plane still blew up. So after that second crash, Sir Arnold Hall led the investigation, and they took, like you can see in the picture here, they took the plane cabin and put it in a giant water tank, and then they pumped water into it and tried to adjust like the pressure coming in out of the cabin until they could figure out where the failure occurred, and they found very similar results in the water to the actual cabin depressurization. So the root cause of the entire failure is that the windows in the front of the plane were made with squares instead of being rounded. They had square corners. So all the plane stress, or 70% of the ultimate stress of the airplane, was concentrated onto the corners of the windows at the front of the plane. And additionally, these supports were punch riveted instead of glued. And punch riveting causes a lot more rougher holes in the surface instead of like a smooth glue or adhesive. It was easier for the material to crack after repeated pressurized cycles. So the combination of these two things caused the corners of the windows to break, which is what caused the explosive decompression in the air, which made the plane fail and killed everybody inside.
So, how was the failure fixed? Uh, the sharp edges on the corners were changed to have more round windows. So now, if you go in planes, they have round windows that are in oval shapes, which makes more sense. You don't have as many stress concentration around the window without having the squares, and they also aren't punch riveted anymore. So using the glue and as an adhesive to connect the window to the body of the plane, you have less area for stress concentration around those windows so that failure will not occur. The fix was sufficient because planes still use round windows. We are not having any problems with cabin depressurization and people having their lungs and lungs ruptured and skulls fractured. People were able to fly safely now. From this, I mean, now there are other problems, but this issue is in the past. We are past rapid depressurized cabins due to cracks in the windows. The design improvements, using glue in the windows rather than using the punch riveting is an important improvement. So first of all, you have less stress concentration due to that, and it also will most likely reduce the weight added on the plane. So having using stronger material, stronger and lighter material, it's better all around for the plane. You're not going to have as many failure. You're not going to have failure occur. You're going to be able to not have any cabin depressurization, and then using the smoothed hole instead of the rough for bolted supports. So using different manufacturing techniques to allow for better shaped windows and better supports on those windows will allow for less failure, and which is where we are today. And here are our references. So if you would like to learn more about this flight and how it changed the manufacturing for flight cabins, please check these links out. Thank you very much for listening. If you have any questions, please comment below and ask us anything. Thank you for watching.